Assalamu alaikum students. Today we start chapter 1 function and limits, exercise 1.1, introduction about functions. Functions are important tools by which we describe the real world in mathematical terms. They are used to explain the relationship between valuable quantities and hence play a certain role in study of calculus. Concept of function. The term function was recognized by a German mathematician Leibniz to describe the dependence of one quantity on another. The following examples illustrate how this term is used. The area of a sphere depends on one of its sides x by the formula a is equal to x square. So we say that a is a function of x. The volume v of a sphere depends on its radius by the formula v is equal to 4 over 3 pi r square. So we say that v is a function of r. A function is a role or correspondence relationship relating two sets in such a way that each element in the first set corresponding to one and only one element in the second set. Thus, in above, a sphere of given side has only one area. In a sphere formula, radius has only one volume. Now we have formal definition. A function f from a set x to a set y is a rule or correspondence that assign to each element in x a unique element y. The set x is called the domain of f. The set of corresponding element y in y is called the range of y. X is called domain and y is called range. Unless stated to the contrary, we shall assume hereafter that the set x and y consist of a real number. If a variable y depends on a variable x in such a way that each value of x determines exactly one value of y, then we say that y is a function of x. Mathematician Euler invented a simple way to write the statement y is a function of x, y is equal to f of x, which is read as y is equal to f of x. Functions are often noted by the letters such that f, g, h, capital F, gh, and so on. A function can be thought as a computing machine f that takes an input x, operate on it in some way and produce exactly one output. The output is called the value of f, x or image of x under f. The output f of x is noted by a single letter, say y, and we write y is equal to f of x. The variable x is called independent variable of f and the variable y is called dependent variable. From above diagram we have input x, then we function on it and it change to f of x. Like if we put in x square, then it gives 4. For now onward we shall only consider the function in which the variable are real numbers, and we say that f is a real valued function of real numbers. Now we have example. f of x, x cube 2x square plus 4x minus 1, and we find value f of 0. How to find this value? We replace x by 0 in the question, and we get the answer is minus 1. In second part, we put 1 in place of x and then simplify. In third part, we place x by minus 2 and then simplify it. And in fourth part, we replace 1 plus x in place of x. Here 1 plus x whole cube. Cube formula is a cube plus 3ab plus 3a square plus a cube plus 3a square b plus 3ab square plus b cube, and square formula is a square plus b square plus 2ab, and then simplify. In next part, we replace f of x, f of 1 over x, we replace x by 1 over x and then simplify it. Now in this example, we find the domain and range. For every function, the domain is real number and range also real number, except some values where the function gives undefined values. Now here f of x is defined for every real numbers. Further, for every real number is non-negative real number, so domain of f, we put all real numbers, but when we put the negative numbers, it also convert to positive, so their range is non-negative real numbers. Now in second example 3, we have a function x over x square minus 4. In this function, if we put x is equal to 2 or x is equal to minus 2, it gives undefined answer, because in denominator there comes 0 and something over 0 is infinity. So we eliminate 2 and minus 2 from the domain. It means domain of f is set of all real numbers except minus 2 and 2. Range of f, set of all real numbers. In example 4, f of x, x square minus 9. Find the domain and range of f. Now here we have square root sign. Square root gives iota when we put negative value. Now we check where it comes negative value. No real number y is equal to exists, so domain of f is minus infinity to 3 and 3 to infinity, because if we put the values between minus 3 and 3, it gives negative inside square root and it gives iota. So we eliminate the area between minus 3 and 3. Real line covers minus infinity to infinity, and we eliminate the portion minus 3 to 3, because between minus 3 to 3 it gives negative answer, so we write it as minus infinity to minus 3 and 3 to infinity. Now range of f, set of all positive real numbers, because for every number we put in this function, it gives positive answer, and positive is from 0 to plus infinity. This is its range. Graph of algebraic function. If f is a real valued function of real number, then graph of f in xy plane is defined to be the graph of the equation f of x. The graph of a function f is set of points. X is in domain of f in the Cartesian plane. Where we draw the graph, it is called Cartesian plane. Is an ordered pair of f, x and y. When we write in bracket, it is called ordered pair. The graph provides a visual technique for determining whether the set of points represent a function or not. If a vertical line, when we draw a graph and we cut it by a vertical line and intersect a graph in more than one point, it is not a graph of a function. In first figure, we draw a vertical line, it cut only once, so it is a function. Second is also a function, but this is a circle. It is not a function because when we draw a vertical line, it cut it at 2 points. And last, also not a function because when we draw a vertical line, it cut it more than once. Method to draw the graph. To draw the graph of f of x, we give arbitrary values of our choice to x and find corresponding values of y. In this way we get ordered pair, and these ordered pairs represent points of the graph in the Cartesian plane. We add these points and join them together to get the graph of the function. Find domain and range and function and draw its graph. This is quadratic equation defined for every real number, because when we put any value it gives the real answer. Domain of f set of all real numbers. Range of f set of all non-negative real numbers, because we have a square and negative convert into positive values. Here we put some values of x, -3, -2, -1, 0, 1, 2, 3. When we put -3 in the function, -3 square is 9 plus 1, it gives 10. When we put -2, square of -2 is 4 plus 1 is 5. And same way we have some values there. Plotting the points and join them with a smooth curve. We have values of x and y. We plot -3 and 10, and then other values and join them, and we get the graph. X-axis is horizontal line, y-axis vertical line. We draw these numbers on these lines and then join the graph. Graph of a function defined piecewise. When the function f is defined by two rules, we draw the graph of two functions as explained in the following example. Domain and range of function and its graph. We have this type of function is called piecewise. X, its limit is from 0 to 1. X minus 1, its limit is 1 to 2. Now here domain is 0 to 1 and then 1 to 2. Total limit is 0 to 2. Now graph values for both functions. One function is x and other is x minus 1. values of x from 0 to 1, 0 to 1, and between them 0.5 and 0.8, any decimal numbers between them. And from 1 to 2 we have 1.1, 1.5, 1.8 and 2. The first table is same values, but in second table we subtract -1 from the values of x, and then we plot these values on the graph. These two lines, one for y is equal to x and other for x minus 1. Next is type of function. Some important types of function are given below. Algebraic function are those functions which are defined by algebraic expressions. We classify algebraic function as follows. Polynomial function, a function p of the form where x power n, x power n minus 1, n minus 2 to constant, where the coefficient are real numbers and exponent are non-negative integer, is called a polynomial function. The domain and range in general subset of real number is called polynomial function of degree n, and an is the leading coefficient. For example, 2x power 4 maximum value is there. Polynomial function of degree 4 because highest power of x is 4 and leading coefficient is 2. Linear function. If the degree of a polynomial function is 1, then it is called linear function. A linear function is of the form ax plus b. For example, 3x plus 4, we replace f of x by y. Its domain and range are real number. Next is identity function. F of x is equal to x. We draw its graph in last example. Is called an identity function. Its domain and range is the set of x itself. F of x for all x belongs to R is the identity function. Now remember, y is equal to x is an identity function and also called linear function. Now constant function, function c x tends to y defined by cx equal to a is called constant function. Example is c of x is equal to 2 or any number is a constant function. Rational function, a function in the form of px over qx, where px and qx are polynomial functions and qx denominator is never equal to 0. Domain is a set of all real numbers x for which q of x is equal to not equal to 0. In example number 2, we solve this where we have the function x over x square minus 4. Now trigonometric function, y is equal to sine x, and then its domain is real number and its range we define in the last class in 11.1 and 2. Maximum limit is 1 and minimum limit is -1, and same for cos x. For tan x, domain is real number except those values where tan is infinite, and these are the odd multiple of pi over 2, 2n plus 1 pi by 2, and range is real number. For cot undefined at multiple of n pi, and range is x, secant x, and secant x same as tan x. Limits cosecant is like cot x. Domain and range of tan and secant and cot and cosecant are same, and sine and cos are same, but here is cosecant, and in secant also our range is from above 1 and below -1. Also change in secant, range of cosecant and secant are same because it is opposite of range sine and cos. Their range are between 1 and -1, and their range beyond these limits. Now we have inverse trigonometric function. We denote and define inverse trigonometric function as follows: y is equal to sine inverse x, y is equal to cos inverse x, and y is equal to tan inverse x, and their limit is from minus pi by 2 to pi by 2 for sine inverse, and for cos inverse y greater than equal to 0 and less than equal to pi. Tan is from minus pi by 2 to pi by 2. Both are inclusive, not inclusive, sorry. Exponential functions, a function in which the variable appear as exponent, is called an exponential function. The function like y is equal to e raised to power ax, e raised to power x, 2 raised to power x is called exponential function in which the variable in the power. Next is logarithm function. X is equal to a raised to power y, and then it becomes y is equal to log base ax, called logarithm function of x. If a is equal to 10, then we have, and is known as common logarithm. If a is equal to e, then we have log ex, which is known as natural logarithm. Next is hyperbolic function. For hyperbolic function sine hx or sine hyperbolic x, its value is 1 over 2 e raised to power x minus e raised to power minus x. The mean and range are real number. And for cos hyperbolic x, its formula is 1 over 2 e raised to power x plus e raised to power minus x, and its mean and range given. The remaining 4 hyperbolic function, if to learn first 2 and then find all 4 next values, because tan is sine over cos and cot is cos over sine, reciprocal of tan, secant is reciprocal of cos, and cosecant is reciprocal of sine. Only first 2 values are important, and then we convert all these values. Inverse hyperbolic functions. Sine hyperbolic inverse x, its value is ln of x plus x square plus 1, and in same way all other values. Learn these formulas for objective. Next is explicit function. If fy is easily expressed in terms of the independent variable x, then y is called an explicit function, like y on left hand side and x on right hand side. These are called explicit function. And implicit, if x and y are so mixed up and y cannot be expressed in terms of the independent variable x, then y is called implicit. In mixed form like this, x square plus xy plus y square is equal to 2, these functions are called implicit. Parametric function. Sometime a curve is described by expressing both x and y as a function of a third variable t or theta, which is called parameter. The equation of the type are called the parametric equation of the curve. Here x is equal to at square and y is equal to at. X is equal to a cos t and y equal to a sin t. And first parametric equation are of parabola, second for circle, and third a cos theta and b sin theta is for ellipse, and fourth one for hyperbola, a secant theta and tan theta. We discuss about these detail in 6th chapter, and remember these questions for objective also used in questions. Now even function and odd function. A function f is said to be even if we replace x by minus x in the question and it gives the same answer. Like f of x is equal to x square, we replace x by minus x, it gives the same answer. And if we replace f of x cos x by minus x, it gives also same answer. These two functions are even function. Odd function. F is said to be odd function if we replace minus x and we get minus f of x. The example is f of x is equal to x cube. If we replace minus x, it gives minus x cube and negative sign, and f of minus x sine minus x is equal to minus sine x. These are odd functions. Show that the parametric equations x equal to a cos t, y is equal to a sin t is the equation of the circle x square plus y square is equal to a square. The parametric equations are a cos t, a sin t. And we put these values in equation, or we square it and add these values. Here we have parametric equation in question, and we show that this is the equation of circle. We square these values and then add them. Cos square plus sin square is equal to 1. Therefore it shows that these are the equation of parametric equation of a circle. Now in this question we use hyperbolic formula. We know that sine hyperbolic x value and cos hyperbolic x value, and we take square of these values. In numerator, a square plus b square minus 2ab, and cos hyperbolic square a square plus b square plus 2ab. Then we subtract these values and we get the answer. In next part we square these values and add these values. Now at the end we get the value e raised to power 2x and e raised to power minus 2x, and between them is a plus sign, and it is equal to cos hyperbolic 2x because in the power there is 2x. If there is 3x, then it gives cos hyperbolic x 3x. So in this example we show that even or odd function. In first part we replace x by minus x and there is no change in the function, therefore this is called even function. In next part we replace x by minus x and it gives minus f of x, so this is an odd function. In third part we replace x by minus x, but it is not equal to f of x and neither equal to minus f of x, therefore this is neither even nor odd. I hope you understand all these examples. Try to solve each examples and revise the lesson. Thank you for watching. Jazakallah.